we want to calculate the limit as x approaches 2 of the fraction x minus the square root of the quantity 2x, all divided by x minus 2. If we plug in x equals 2, we get 2 minus the square root of 2 times 2 divided by 2 minus 2, and this is 0 over 0, an indeterminate form. So we have to figure out some way to circumvent this situation, and in the case of working with radical expressions like the square root of 2x, we want to use what's called the conjugate radical. And what that means is that we're going to take the original fraction and we're going to multiply it by the conjugate of the numerator. The conjugate in mathematics, the conjugate of two terms, means just take the opposite sign of that's between the two terms. So this one's a minus, so make this one a plus. These two expressions are what are called conjugates, and then we have to multiply on the bottom by that as well. That way we're just multiplying by the number 1. This whole fraction is just a fancy number 1, and multiplying by 1 doesn't change the value of the original fraction. So now we have to combine these. We're not interested in combining the conjugate with this other term here on the bottom that's not a conjugate. The point of conjugates is that they multiply well. So when we multiply these numerators together, something nice is going to happen. But the denominators not being conjugates, we really don't want to multiply them together. So we're just going to indicate the multiplication by putting them next to each other here. And our ultimate goal, when you have a 0 over 0 plugging in a particular number, is to get x minus that number to cancel. So there's the x minus 2. We don't want to mix it with these other terms by doing like a distributive property, a FOIL method. That would be a waste of time. We want to cancel this x minus 2 here. Now, in the numerator, this is where the action happens. This is the reason for the method. We have something that looks like a minus b, a minus b, and then we're going to multiply that by a plus b. This one is a plus b. And when you multiply a minus b times a plus b, you get a squared minus b squared from foiling it out. Double check that. And that's an extremely useful formula. The difference of two squares factors as a plus b times a minus b. And these two are conjugates. So multiplying conjugates gives you the difference of the squares. So here, when we multiply, we're going to get x squared minus the square root of 2x squared, and the square root and the square cancel out, and you get 2x. So we get x squared minus 2x. And now again, keeping in mind that the ultimate goal is to cancel x minus 2, in the numerator, we can factor, just take out an x, and it's x times x minus 2. And in the denominator, we had an x minus 2 already. And now you can see why we didn't want to mix it with this one, because now the x minus 2's will cancel. So x minus 2 cancels with x minus 2. And then in the next step, our limit is just x on the top and this conjugate radical on the bottom. And now we plug in again. Once we've canceled the x minus 2's, it should be safe to plug in and get an answer. So if x is 2, we get 2 over 2 plus the square root of 2 times 2. and this is 2 over 2 plus 2, and that reduces to the final answer of 1/2. So the limit is 1/2.